Good afternoon, everyone. All right, today's lesson we're going to talk about word problems with linear equations. Here's the thing, I need everybody's attention. We've done this all before. We've done this several times before, and this is the hardest thing we have done in this entire year so far, and we're not doing well on it. So I really need you to bring your attention, I need you to bring your brain, and I need you to try to understand what I'm talking about. Please rewind if you need to figure out anything that I have said. If it didn't make sense to you, rewind and listen to it again. Try to bring your brain and engage it for this lesson, please. All right. First thing we're going to do, we're going to fill out this first page. The forms of linear equations I know. I should hope that we are all able to fill this out with ease at this point. Here are the forms that you know. Y equals mx plus b. Y minus y1 equals m times x minus x1. Notice how I took too much space for that one? Yeah, that's because these three, this one right here, and this one right here, and this one right here, you're going to fill in yourself. By this point, you should be able to recite all 5 of them, or look in your notes and recite them from there. Moving on. When can I use these equations? Maybe we haven't spent enough time figuring that part out, and that could be my fault, but let's try to figure out when am I able to use these 5 different equations? Well, anytime I have a problem that has a linear relationship. I want you to write something else. You probably don't have room for it, but we're going to find room, okay? It has a linear relationship. This is another way of saying has a constant or constant rate of change. Okay, these are the times that we are allowed to use these formulas. We can only use them when we have linear relationships, which means that y grows consistently at the same time that x grows consistently. When we graph it, we will have a straight line. This means we have a constant rate of change. These are all ways of saying the same thing, the same concept that we should be getting by now. Well, how do I know if I have a constant rate of change? Well, one way is usually if the words per or each show up in the problem, okay? An example, I make $5 per hour, okay? Or my grade goes up, let's say 10 points for each 20 minutes I study. Okay? Okay, that's one way we know that we have a constant rate of change. Another way, if I am told I have a constant rate of change. That one seems so obvious, but if it says I have a constant rate of change, your mind should immediately be thinking, yay, linear equation time. Okay? Or if I am given any other information that seems like, what is one thing that all linear equations have in common? Like that one I just drew right there. Anytime it looks like I have a constant slope. Okay? Linear equations are unique in that they are the only ones that the slope is the same at all times. So anytime I'm given something that looks like a slope that doesn't change, good chance that we're going to be using linear equations. Okay, now let's do some word problems. Number 1, your grandmother bought a gold coin 46 years ago when it was new. The gold coin has appreciated. That means gone up in value. $12 each year. Hey, you see that? Each year. That looks like a constant rate of change to me. It's changing $12 for each year. Okay, I can use my linear equations now. The coin is now worth $1,000. How much was it worth when it was new? What about the year after it was new? First of all, notice I've got 2 questions here. Do not forget to answer both of them. Now we need to go back and we need to create an equation. Do not, I repeat, do not try to answer this some other way. Is it possible to answer it some other way? Yes. Does that teach us what we're trying to learn here? No. Is my way the easiest? Almost always. Okay? You must do it my way. Your grandmother bought a gold coin 46 years ago. So there's one piece of information I have right now. And it was new at that point. The gold coin has appreciated, gone up in value, $12 each year. The coin is now worth $1,000. This is enough information for me to fill out my easiest form of an equation, y equals mx plus b. All of the ones we do today are going to be in this form, not because there aren't others that would work, but because this is the easiest one to use and usually the most useful. Okay, now my first thing is, what can I replace? Often, if we are given the rate of change, that's the thing that happens each something, that's my slope. My slope is $12 per 1 year. Okay? And so what this means, remember, slope is equal to change in y over change in x. This means that my y is really dollars. And my x, let me pick a different color, is really years. So I'm going to replace these, the x and the y here, with dollars and time. Okay, so time and money, okay? Or, yeah, I guess we'll just do money. So I'll say y equals money. And that's going to be measured in dollars. And x is going to equal time, and that's going to be measured in years. Now that I have that, look what I'm going to do. I'm going to not have y equals mx plus b. I'm going to write yeah, no, I am going to write y equals mx plus b. I apologize. Because I've got this, this right here, this reference table. That'll be enough for me to refer back and figure out what y and x equal. But I need to refer back to this as I'm going through. All right, so the first thing I can put in is my slope. Y equals, my slope is $12 each year, so 12x plus b. Now all I need is my b, and I've got my equation done. Well, I am not given my y-intercept, because my y-intercept is when x is 0, or when time is 0. I am not told what that is. That's actually one of the things I want to find out. But I am told one other piece of information. The coin was bought 46 years ago, so time is x, money is y, so time comma money, that's a coordinate point that I have. And so one point that I know exists on this linear equation is 46 years, comma, how much is it worth now? $1,000. So this is one point I have, and I can plug this in temporarily for x and y in order to figure out what b is. Okay, so follow me here. Y equals 12x plus b. And y is going to be replaced temporarily with 1,000. X is going to be replaced temporarily by 46. And I get plus b. I sure hope that this works out, because I did pick these numbers at random. And we're going to get screwy answers if we wind up with something like our initial value was negative, meaning the coin was actually worth negative money when we bought it. Let's hope that doesn't happen. I'm going to use my calculator. 12 times 46 is 552. So 1,000 is equal to 552 plus b. So to figure out what b is, minus 552, minus 552, I wind up with b equals 448. Okay, so I now need to take my x and my y and leave them as x and y. So my equation is y equals 12x, but b is going to be replaced by my number 448. So This is my equation that explains how much my coin is worth at any time, okay? At any time for this equation. So all I need to do now is figure out what is the question asking? How much was it worth when it was new? Okay, when was this coin new? How many years had passed since I bought it? The correct answer is not 1, as most of you are probably guessing. The correct answer is 0. Y is equal to 12 times 0, because when time is 0, that means it's new, plus 448. Well, 12 times 0 is just 0, and so y equals 448. This is how much it was worth when new. And my next question, I'm going to use the same equation, but I'm answering a different question now. What about the year after it was new? A couple ways you could answer that. You know it appreciates $12 each year, so 448 plus 12. Or you can just use your equation to get good practice on it. Y equals 12x plus 448. What is the year after it was new? That's when x equals 1. So y equals 12 times 1 plus 448. So y equals 12 plus 448. Y equals $460. That is my answer. Year after. Let's go on another one. If you're a little bit confused, you can go back and re-listen to part of it, or we can just do another one and see if they start to get a little easier. Savings bonds are pieces of paper that the government issues, like money, but they gain a little bit of value each year. And some of you probably even have savings bonds right now. A $50 savings bond will be sold for $25 and will be worth $25 when it's new. Each 3 months, it will go up in value 47 cents. How long after it is issued, which we call time zero, remember, time zero is the beginning time usually. How long after it's issued will it be worth $30? How long will it take to mature? Okay, so let's make sure I underline my questions. How long after it's issued will it be worth 30? How long will it take to mature or be worth face value of $50? Notice what I've done as I went through this. All I did was I went through and I circled or underlined all of the important pieces of information. I don't know what exactly is important, but all my numbers are going to get underlined, and then I just need to go back and try to figure out what is my rate, my slope. Slope is equal to change in y over change in x. But what here is happening every certain something? Well, it goes back to right here. Each 3 months, notice that word each again, it goes up in value 47 cents. So 47 cents per 3 months. 47 per 3 months. This is my slope here. Notice, once again, my y is equal to money, and my x is equal to time, but this time it's in months. I'm going to go back and write this over here. Y is money in dollars. X is time measured in months now. The last problem we were measuring in years. Now all our things need to be measured in time or months. Okay, I have my slope. My slope is 47 divided by 3. Okay, in order to put this into our equation, we're going to need to change that a little bit. Y equals mx plus b. Y equals 47.47 divided by 3, x plus b. It's going to be a little hard to work with on our calculator, so what I'm going to do, I'm going to divide 0.47 divided by 3, and I'm going to get something that's not going to be quite exact, so most of our answers are going to be estimates. Y is approximately equal to 0.16. Okay, it was really 0.1566666666. I'm going to round it up to 0.16x plus b. Now, once again, notice there's a trend here. I'm trying to find b in order to have my equation. So I need to go back and figure out what piece of information am I given? Well, it might be a little bit harder to see on this one, but it will be worth $25 when it is new. That is enough information to fill out X and Y temporarily, because Y is my price. It is worth $25 equals 0.16. Let me change the color back to purple for that part. Equals 0.16 plus B. And what is my X? My X is when new. What is the time value when my savings bond is new? It's 0. Okay? So look what happens here. 0.16 times 0 is just 0, and B, my y-intercept, is $25, which makes a lot of sense because remember what the y-intercept means is what is the value when time is 0 or when x is 0? Well, when I buy it as new, I pay $25 for it, so that's my y-intercept. I have enough information to make an equation. My equation I'm going to write over here, y equals 0.16x plus $25. That's my equation. Now I have two questions to answer. How long after it is issued, which we call time 0, will it be worth $30? Well, which variable am I replacing 30 with? It's the money, which is y. 30 equals 0.16x plus 25, and I need to figure out how long or what the value of x is that makes this true. Minus 25 minus 25. 5 is equal to 0.16x. Am I done? No, I'm not done. Divide by 0.16. Divide by 0.16. 5 divided by 0.16. I'm going to use my calculator. I get 31.25. 31.25 is equal to x. Well, what does this actually mean? Let's go back to what x is. We see that x right here is time in months. So I go down and I say that this must mean that for my problem, I get that x is equal to 31.25 months. 31.25 months, or when you consider that 12 months is a year, a little less than 3 years before this is worth $30. Okay? But that is my answer. I have another question to answer. How long will it take to mature or be worth face value of $50? Keep in mind, I use my same equation. Y equals 0.16x plus 25. But this time, I want my value to be $50. So when is y 50? 50 equals 0.16x plus 25. So take away 25 from both sides. When is 0.16 equal to 25? Divide both sides by 0.16. Divide by 0.16. X is equal to, I'm going to use my calculator, 25 divided by 0.16, 156.25. What is x measured in again? This is months. But if you wanted to convert it into years, you just divide by 12. So the answer is here. But if I want it to be a little bit easier to understand, x is about, and when you divide that by 12, you get about 13 years. Okay, either way you want to go with that one. I'm going to move on to the next one. Word problem number 3. I'm just going to check. Yep, word problem number 3. Children's growth can be modeled with a linear equation. Hey, this tells me right here I'm allowed to use my linear equation because it says I can model this with a linear equation. Yay! Without much error until the time they're about 18. Okay, so this only works until we're talking about age 18. Let's just keep that in mind. If Jerome grows about 4.5 inches per year, there's my word per again, so I'm pretty sure my slope is 4.5 inches per 1 year. Okay, and so I know that my delta y, my change in y over change in x, my y must be 4.5 inches. I'm sorry, not 4.5 inches, I apologize. My y must be height, which is going to be measured in inches. Okay. And my, let's see, my x is going to be time, which, how are we measuring time now? Looks like in years. Okay. So just keep in mind, all my units need to be in inches and years. So now, if Jerome grows about 4.5 inches per year, and at age 17 is 6'3", about how tall or long, and when you're talking about babies, sometimes they talk about how long a baby is because they don't stand up a lot. How long or tall was he when he was born? All right, so the only other piece of information I'm given are right here, and so that must be what I'm talking about. Age 17, 6'3". But keep in mind, what are my units? Inches and years. Okay, so it's pretty obvious that age 17, how many years after birth is that? Well, that's 17 years. My units are correct. But for 6'3", that is not in inches. 6'3" means 6 feet plus 3 inches. Well, how much is 6 foot in inches? Each foot is 12 inches. So 6 foot times 12 inches, that's 72 inches plus 3 inches. So we are talking about 75 inches and 17 years. That's my data point there. I cannot say 6'3" or 6.3. Anything you try without converting it into inches is going to be wrong. You must be in consistent units. Okay, so I've got my slope. It's over here, 4.5 inches per year. I've got my data point, 75 inches, 17 years. I am ready for this problem. Bring it on. Y equals mx plus b. Y equals my slope, m. It is 4.5. X plus b. Now I know I should probably temporarily replace y and x with something. Everything else is going to stay the same. So I'm just going to leave it the same. Well, what's y? My y is my height. I know I have 75 inches. So I'm going to replace my y with 75. And my x is time in years. That is going to be 17. Now all I got to do is find b, and I'm ready to start answering questions. 75 equals, I'm using my calculator, 4.5 times 17 is 76.5. Plus b. I'm going to pause this for 1 second, just make sure I didn't make a boo-boo. Hold on. And I'm back. Okay, so it does appear that when I picked my numbers randomly, this is not going to make sense, and here's why. It doesn't mean we can't do this problem, though. Okay, look what happens on my next step. Minus 76.5 minus 76.5. This is negative 1.5 is equal to b. So my equation is y equals 4.5 x minus 1.5. If you think about what the y-intercept means here, that means that when x is 0, or when the baby is just born, because time is 0, then the value of his height is negative 1.5 inches. Clearly, that doesn't make a lot of sense, but we're going to go with it so that we can finish answering these questions. Okay? So if Jerome grows about 4.5 inches per year and at age 17 is 6'3", about how tall or long was he when he was born? Only one question here. How tall was he when he was born? Well, that's when x is 0. 4.5 times 0 minus 1.5 equals y. This whole thing is 0, and so Jerome must have been negative 1.5 inches tall. This clearly is nonsense, but if I gave you this on a test, I would have to give you full credit because I didn't make sure that my numbers made sense. In the real world, numbers generally make sense. Okay, we're moving on to the last one now. Alicia just had her 15th birthday. She got a generous monetary gift from her grandmother, which she decided to put in a piggy bank. She also decided that she would take her $5 allowance each week and put it in the piggy bank as well. Hey, there's that word each. I wonder if that's going to be our slope kind of thing. And put it in the piggy bank as well. After 37 weeks, she had $1,554 in her piggy bank. How much did her grandmother give her? How long will it take her to have $2,000? Okay, there's two questions here. Oh, I meant to do that in green. Two questions here. How much did her grandmother give her? How long will it take for her to have $2,000? Let's think about what my slope is. My slope, change in y over change in x, is equal to $5 allowance per 1 week. Every week she puts in $5. Okay? So this must mean that y is equal to money in dollars, and x is equal to time in weeks. And make sure all of your units are in these same, or all of your answers are in these same units, dollars and weeks. You should not be using days, you should not be using years, you should not be using cents. You need to make sure you have it in dollars and weeks. Okay, I'm ready. By this point, you should know that you're doing y equals mx plus b, and you're looking for your slope, which is given to you, hey, $5 per 1 week. Y equals 5x plus b. I now need a y and an x to put in there temporarily. Well, what information am I given? I bet I could find some if I looked real hard. After 37 weeks, that looks like time. I had 1,554. That looks like money. Let's put them in where they go. 1,554, if I remember correctly. 1,554. Yep. Equals 5 times how many weeks? 37. Plus b. B is what her grandma gave her. I'm just giving you a hint. Okay. 5 times 37, I'm going to use my calculator. Don't really have to, that's easy enough to do, but I want to make sure I don't make any mistakes. 5 times 37, 185, is equal to 1,554, and then the 185 we add b to. Okay, minus 185, minus 185. Going to use my calculator again. I get 1,369 is equal to b. So I know now my equation, y equals 5x plus b, which is 1,369. This will allow me to answer all of my questions. How much did her grandmother give her? Well, remember, her grandmother gave her what we have when the number of weeks she's put stuff from her piggy bank in as well is 0. She hasn't put anything in from her piggy bank when her grandmother gave her this money. So 5 times 0 plus 1,369 is equal to how much money she has. That is 0. So her grandmother gave her, grandma gave $1,369. My grandmother usually gives me gifts in very round numbers like that, 1,369, 462 and 21 cents. You know how it is, grandmothers. Second, how long will it take for her to have $2,000? Well, we're going to use the same equation. Y equals 5x plus 1,369. But I now know that my money is $2,000. Money, remember, is y. So 2,000 equals 5x plus 1,369, and I want to know what x is. That's how many weeks. So minus 1,369. Minus 1,369. Going to use my calculator again because that's what I do. I get 631 is equal to 5x. Divide by 5. Divide by 5. Use my calculator again. Divide by 5. 126.2 is equal to x. Okay? So after number of weeks, so number of weeks until 2,000 is 126.2 weeks. Probably you're going to end up having to wait 127 weeks if you're only getting your money at the end of the week. But if for some reason your parents give you a certain amount in pennies every day for your allowance, then you could maybe do it in 126.2 weeks and have $2,000 in your piggy bank account. I would like you to answer this your turn question. Do the best you can, and I will see you tomorrow.